we get started on the new note sheet, is there any questions over any of the previous assignments thus far? Question on any of the homework? Any that y'all want to see done or worked? One 1.5 is system of equations, systems of equations. Now, you've done systems of equations before. In Algebra 1, we've done two variable systems of equations. We had two equations with two variables, and we wanted to find the point or line that was the solution. A solution for a system of equations with three variables or two variables is an ordered triplet for three variables of three equations that satisfies all three statements. Really, we're looking for a point that makes all three statements true. That if we plug that point in, those three values, the values for x, y, and z, into each of these equations, we'd get a true statement. The left side would equal the right. So we would look for a value of x, y, z. That would make 3x plus 4y minus 8z be negative 3. Those points would also make x plus y plus 5z be negative 12, and 4z minus 2, or 4x minus 2y plus z equal 10. We're looking for that point, or that set of values. Now, there's three main solution types that we can have. One of them is exactly one solution. There is a single point, a single value for x, y, and z that will make all three statements true. Or we have infinitely many solutions. Infinitely many solutions is a line. All the points that lie on this line will make all three equations true. We're going to call that infinitely many. Now, it's not going to be all real solutions because there are still points that don't make all three true. For example, this point here, whatever the x, y, z value of that point does not make all of them true because it's not on that line. So infinitely many, there's an infinite number of solutions that work, but they have to satisfy certain conditions. They have to be on that line. So we can have one solution, we can have infinitely many, or we can have no solution. And for this first one here, this first setup, at this line here, two of the planes do intersect, but not all three. We need all three. The top line here, we do have, again, two planes, because a x, y, z, a three-variable equation is going to be a plane. Two of them meet, but not all three, and the same with this here. Again, at each of these intersections, we only have two of the planes. We only have two of the equations true, not all three. We need all three. Same with this one in the middle. We have two spots, two lines where two of the planes cross, but not all three. So it's not going to be a solution. We will not have a solution. Or we have the last one where there is no intersection at all. They're all three parallel. There is no solution. So when we look at systems of equations, we either have one solution, infinitely many, or no solution. It's going to fall in one of the three groups. Now, we do have set steps to solving this here. And this is included in your note sheet. It's right there on the first page. Step 1, rewrite the linear system in three variables as a linear system in two variables. Solve the new linear system for both of its variables. Substitute back in this here. If we obtain a false statement at any point, we obtain a false statement. 0 equals 1, 0 equals negative 7, 2 equals 5. An equation that is not true ever. It is no solution. We're done immediately. Because what that's saying is that two of the planes do not cross. They do not intersect. There's no solution for those two there. And again, for us to have a solution, all three must cross. All three must intersect. So if two of them don't, it doesn't matter what the third one's doing. There is no solution because they don't cross. If we get an identity, 0 equals 0, we get a true statement. That means there's a good chance that there's an infinitely many solutions. We just need to make sure that the other set don't give us a false statement. Because it could be true that two of them pretty much share all points or have a line, but the other doesn't. We still have no solution. Now we have this here in this setup. Right below it, let's actually kind of make some steps that are going to help us kind of what we're doing and kind of flesh out what this is. Now the first main step is to select a variable to eliminate and eliminator equation. Because what we want to do in the first main step is take this from 3 equations with 3 variables down to 2 equations with 2. Because all the way up to this point, we have never actually solved more than 1 variable at a time. We've been able to solve for 2 variables, but we had to find the value of one of them first before we could find the other. We cannot just solve for x, y, z all at the same time. We need to solve for one to be able to solve for the second, to solve for the third. So to do that, we're going to get rid of one of the variables. So that's the first step, is we need an equation to get rid of either x, y, or z. We figure out which one we want to get rid of and the equation we're going to do to get rid of that variable. So the first step is to select a variable to eliminate in an eliminator equation. We then eliminate it. The second step is to, again, select a variable and eliminate it. Because we're going to go from 3 equations with 3 variables down to 2 equations with 2. With those 2 equations with 2 variables, we need to select another variable and eliminate it. And once we get after that, we should have 1 equation with 1 variable. Solve for remaining variable and work backwards. So we want to select, so we start off, we select a variable to eliminate and an eliminator equation to get rid of it. We're going from 3 variables and 3 equations with 3 variables. We do this to go down to 2 and 2. Our second step is taking those 2 equations with 2 variables, eliminating one to go down to 1 equation with 1 variable. We're going to solve. We're down to 1, we can solve for 1 and work backwards. Work backwards is going to make sense once we actually see it. This process has a lot of steps involved, but for the most part, each group of steps is going to be repeated again and again and again. So let's actually see how this works. So we're given this here. We have 3 equations with 3 variables. 4x plus 2y plus 3z equals 12. 2x minus 3y plus 5z equals negative 7. And 6x minus y plus 4z equals negative 3. First main step is we want to eliminate a variable or select a variable, x, y, or z, to eliminate, and an equation we're going to use to get rid of it, to eliminate it from the other 2. Now the question is, how do we know which one to pick? The way I look at it and the way I decide which one I want to pick is which one can I make the smallest variable of that group into the other 2. So let's look at x. So in the x's, we have 4x, 2x, and 6x, yes? If I'm going to choose x or x as a possibility, we look at, so the smallest one is 2x, yes? Can I multiply 2x by something to get 4x? And it would be 2. 2 times 2x is 4x. Can we nicely make 2x into 4x? Yes. Now the other question is, can we do the same thing but make it be 6x? And then we'd multiply it by 3. So when I look at this here, x, I would consider a good choice to start with. Because we can turn 2x into 4x, we can turn 2x into 6x. Because for us to eliminate it, we need the numbers, we need those terms to be the same so that we can add or subtract to get them to go away. let's look at y. Always start with the smallest. We want to go up. We do not want to go down. I don't want to try to turn 3y into 1y. Because to do that, we have to divide. Because if we look at 3y, the other terms are 2 and 5. 2 and 5 don't divide by 3 nicely. Let's multiply. Let's not divide. Now, if we look at the y terms, the smallest one is 1y. Can we multiply it by something to get to 3y? And that would be 3. That would give us 3y, yes? Is there something we can multiply y by to get 2y? 2. So y is also a good choice. We can multiply by a nice number, an integer, to get from y to 2y, y to 3y, yes? Okay. Let's look at z. The smallest term with z is 3z. What can we multiply 3z by to get to 5z? Is there a nice number? No, we'd have to multiply by 5/3. At that point, we're multiplying the 3z by 5, the 5z by 3. We're having to do multiple multiplications. If we can avoid that, we're going to avoid that. So at this point, z is not the nicest choice to eliminate first. We might eliminate it later. We'll see at that point. So at this point, really, x and y, both of them are good choices to eliminate first. Which one do we want to eliminate first? Because it doesn't matter. We just need to pick one. We can do x. So the first part, again, first step is we need to select a variable to eliminate. We picked x. And an eliminator equation. So as we look at these three, 2x was the one that we can nicely turn into the other two, yes? So the equation with 2x is going to be considered the eliminator equation. I would highlight it, select it, so we know that's the equation we're using to remove x from the other two. Its only goal is using it to be eliminated out of the other two. That's what we're using it for. The other two equations, we're going to list down. 4x plus 2y plus 3z equals 12. And our 6x minus y plus 4z equals negative 3. The eliminator equation, we're using it to remove x from both of these equations. That's all we're using it for. Now, to get the x's to be the same, like we said already, we need to multiply the whole equation. Let's make sure I'm not switching equations. 2x minus 3y plus 5z equals 7. So we're going to do the one on the left first. We need the number in front of x is to be the same. Some focus on number and sign. Let's just focus on number. What do I need to multiply 2x by to get to 4x? We already said it. 2, yes? So what we're going to do is multiply the eliminator equation by 2, and not just the x, the entire equation. We need to multiply the entire equation by 2. So if we do this multiplication, 2 times 2x is 4x. 2 times negative 3y is negative 6y. 2 times 5z is plus 10z is equal to negative 7 times 2 would be negative 14. We're going to put it right underneath that equation. Questions on what we've done so far? Yes. Are the 2? Yes. So the main way that this 2 here, yes? So we picked this 2 specifically because what we're wanting to do is get these x's here to go away. We want them to eliminate. Now, the way we eliminate is by adding or subtracting the two equations together. Now, for them to go away completely, we need that number to be the same. So we need to turn 2x into 4x. To do that, we're going to multiply by 2, because 2 times 2x would give us 4x. That's what we're mainly focused on, especially with that product. We're scaling the equation up. We're not actually changing the values, we're changing what they look like. And by doing that, we do get 4x, yes? Now at this point here, we're going to have to add them together or subtract. Now there's two ways to go about this and kind of knowing which one we pick. One of them is we do both operations and see what we get. Because if we added 4x plus 4x would be what? 4x plus 4x? 4 plus 4 is 8, yes? We were wanting it to be what? 0, yes? We want it to go away. 4 plus 4 does not give us 0. 4 minus 4 is 0. So what that tells us is we're going to have to subtract these two equations from each other. So one of the methods is we try both. We try adding, we try subtracting, and seeing which one will cause the variable we want to eliminate to become 0. The other way that I keep it straight is if the signs are the same, we subtract. If the signs are the same, we subtract. If the signs are opposite, we add. So positive, positive, or negative and negative, we're going to subtract. If the signs are opposite, one's positive, one's negative, we're going to add. So let's see what happens. 4x minus 4x. 4 minus 4 is 0. So those go away. That's what we wanted. We wanted x to be eliminated out. We wanted it to be removed. We wanted it to become 0. Then we move on to y. We have 2y minus negative 6y. Our negative and negative make a plus. So we're really looking at 2y plus 6y. 2 plus 6 is going to be 8y. Negative negatives are sometimes a challenge with doing those there. And we know in a calculator, calculators will not do variables. They won't let us plug them in. But they will let us do coefficients, the numbers in front of the variables. Because 2y minus negative 6y is really what? 2 minus negative 6? 2 minus negative 6. We just have to keep track of what the variable is. 8. So it's going to be 8y. Let's move on to the next one, 3z minus 10z. 3 minus 10, so it's going to be negative 7z. 3 minus 10, negative 7, and we have our z. Lastly, we have 12 minus negative 14. Negative and negative would make a positive. 12 plus 14 is 26. 12 minus negative positive 26. Questions on any of the steps so far? We feel okay. I wouldn't say at this point we have it down pat, but we kind of get the gist of what we're doing, yes? We're going to do all of that again with the other equation. So we're going to come back to the eliminator equation. Again, we're still eliminating x. We eliminated x out of the first one. We need to eliminate it out of this other one. So at this point here, we need to see what do I need to multiply this 2x by to get 6x. What do we need to multiply 2x to get 6x? Multiply by 3. So we're going to multiply the whole equation. We're going to scale it by a factor of 3. Because our 3 times 2x is indeed 6x. We wanted it to be 6x. 3 times negative 3y is going to be negative 9y. And 3 times 5z, 3 times 5 is going to be plus 15z. 3 times negative 7 is going to be negative 21. and we put it under the other equation. After this step, after we add or subtract these together, that eliminator equation is not going to be used till the end. Its only purpose is to get rid of that one variable from the other two. Questions on any of this so far? Now, to eliminate that x, we have to either add these two equations together or subtract. If the signs are the same, we subtract. If the signs are opposite, we add. 6x plus 6x, 6 plus 6 is at 0. Now 6 plus 6 is 12. 6 minus 6 is 0. So that means we're going to subtract. Now if you notice on the last one and this one, I always put the signs between all four of the terms, our x's, y's, and the numbers. I do that for myself to make sure I know which operation I'm doing. It is very easy, very common. We start off, we put minus in front, we subtract the first terms, add, add, add. I put it there as a reminder for myself. Also, as we saw in the first one, negative, negative, minus that negative, we can easily rewrite or change them both to plus because we're subtracting. It gives me nice ways to keep track of things. Now we're going to go through and subtract. It is very easy to want to go 6x, 6x, we cross them out, we're done. But just make sure we just go on and check it. 6x minus 6x. 6 minus 6 is indeed 0. We just don't cross it out just so we know we have the right operation. Negative y minus negative 9y. Our negative and negative here would make a plus. So we're looking at negative y plus 9y. 9y minus y would be 8y. 4z minus 15z would be negative 11z. Negative 1 minus negative 9. And lastly, negative 3 minus negative 21. Negative 3 minus negative 21. 18. Negative 3 minus negative 21. The negative and negative would make a plus. So we're looking at negative 3 plus 21. So it would not be negative. So our negative y minus negative 9y, because the negative negative would make a plus. So we have positive 9y. And we're adding to it negative 1y. So 9 minus 1. So it would be positive. That is a good question. Because keeping track of those signs will make a big difference. But any other questions? Does that make sense why it's positive, not negative? Any questions on how we got through the first step? So we have taken it from 3 equations with 3 variables down to 2 equations with 2, yes? Now we're essentially going to be repeating the process. We don't have an eliminator equation anymore, but we need to pick y or z to eliminate out, so we're left with 1. And again, just like with the start, we need to pick one of the two that we can easily turn it into the other. Because if we look at the z's, one's 7, one's 11. So if I wanted to eliminate z next, I would have to multiply the 7z by 11 and the 11z by 7. Not as preferable. So what's the value in front of one of our y's? 8, yes? What's the value in front of the other y? 8, yes? This is nice because the values in front of both y's are already the same. So do I need to do anything to them to make them be the same? No. If one of the variables at this point already has the same number in front of it, that's the one we need to eliminate next. So at this point here, the next variable we're going to eliminate is y. And to do that, we're going to take the 2 equations and rewrite them on top of one another so that we can add or subtract them to eliminate the next variable. Now to do this, to eliminate it, we need to either add or subtract. What do we think? Subtract. 8y minus 8y, 8 minus 8 is 0, yes? If we want to eliminate it, we want it to be 0. So we will indeed subtract, because 8y minus 8y, 8 minus 8 is indeed 0. Negative 7z minus negative 11z. Negative 7 minus negative 11. The negative and negative would turn the 11z positive. So negative 7 plus 11, 11 minus 7 would be 4z. Negative 7 minus negative 11. Positive 4, positive 4z. 26 minus 18 would be 8. 26 minus 18 is 8. Questions on how we eliminated the second variable out? Now, it's not always going to be just this straightforward. We plug it, put them on top of one another, and cancel. We might actually have to multiply one by a number or do essentially what we did on the first two. But at this point, we have one equation with one variable, yes? That puts us to step 3, solve. We just need to solve for z. At any point in the solving process, if you get a variable by itself, solve for it. Solve for it. It's going to make things nicer. Because at this point here, we can divide both sides by 4, telling us z is equal to 2. So z is 2, which is getting us to the solution. I'm just going to put it right here. We have one of the solutions. We have the value of z. It is 2. We have a third of the order triplet. Any questions on how we got to this point? Now, the second half of step 3 was to solve backwards or go backwards. All that means is we're working back up the page. Because again, at any point, we can only solve for one variable at a time, yes? So before we eliminated y, I had two equations with two variables, yes? Y and z. We now know the value of z, yes? Which means I could use either one of these two to solve for y. Which one do we want to use? Doesn't matter, we just need to pick one. Left side or right side? Left. 8y minus 7z. Is equal to 26. But we know what z is now. Z has a value of 2. So we're saying 8 times y minus 7 times negative 7 times 2. 8y minus 7 times 2 equals 26. Negative 7 times 2 is negative 14. Now we do need to get the y value by itself, so we're going to have to move the negative 14. Opposite operation, so we're going to have to add. Since it's being subtracted, we're going to add, because negative 14 plus 14 is 0, leaving us with 8y. 26 plus 14. 40. 6 and 4 gives us 10, carry the 1. 2 and 1 in our extra 10 gives us 40. Last but not least, we need 2. Divide both sides by 8. 8y divided by 8 is y. 40 divided by 8, 5. Now all we're missing is what? X. We have several equations to choose from because we're moving farther up. We actually have 5 to pick from. 5 because we have 3 here, yes? 4, 5. We really have 5 different equations to choose from. Normally, I just pick between the original 3. First equation, second equation, or third equation. Which one do we want to use? First one. So what we're going to do is we're going to take that equation and solve for our remaining variable. At this point, we just are finding space, 4x plus 2y plus 3z equals 12. Now we need to plug in for y, because we found y to be 5 and z to be 2. So 4x plus 2 times 5 plus 3 times 2 equals 12. Now 2 times 5 is 10. 3 times 2 is 6. 10 plus 6 is 16. Need to get x by itself first. Subtract 16 from both sides. 16 minus 16 will cancel, telling us 4x is equal to negative 4. Last but not least, we would divide by 4, telling us x is equal to negative 1. So the solution is the point negative 1, 5, 2. The solution is a single point, and it is that point there. I think we can agree that is a lot of steps for solving one problem, yes? It is not a short problem, but luckily we will not do a ton of problems that are super longer than this. Also, it's going to take less time for you to do it on your own than it is for me to explain through it. There's a lot of dead air between our steps and what we're doing. Also, these sometimes do show up on the ACT. You do not have to work through this entire process because, again, the ACT has 4 answer choices, yes? We are looking for the answer that makes all 3 statements true. And what does that actually mean? Because if this is the solution, I can take that ordered triplet and plug it in. 4 times negative 1 plus 2 times 5 plus 3 times 2. And if this is a solution, it should give me a value of 12. 4 times negative 1 plus 2 times 5.
When the bell rings, all students in FFA, please report to the ag room. Freshmen, go to your class meeting first.
So 4 times negative 1 plus 2 times 5 plus 3 times 2. We type it in, it tells me that this left-hand side is 12. 12 is indeed equal to 12. That is a true statement. Because if I picked, say, letter choice A, I plug it into the first equation, it does not give me a true statement. That answer is wrong. It doesn't matter about the other 2. It has to work for all 3. 2-variable system. It has to work for both equations, make them true. So at that point, if A gave me a false statement, we throw it out. We move to B, do the same thing. Now, if it worked, because it did, we check the next one. We plug it in. 2 times -1 minus 3 times 5 plus 5 times 2. Point, I'd grab the calculator. 2 times -1 minus 3 times 5 plus 5 times 2. Tells me it is. This left-hand side is -7, and it should be equal to -7. It gives me a true statement. Then we can move on to the third equation. 6 times -1 minus 5 plus 4 times 2. And this should give me -3. We can type it in again. So 6 times -1 is -6, minus 5 plus 8. -6 minus 5 is -11. -11 plus 8 is indeed -3. -3 is equal to -3. It is true. It works for all three. That's all it means when we check it. So especially if they give you multiple choice, be plugging them in and checking them and see if they work. Questions on this here? All right. 27. Let's see what time it is. We will start the next one tomorrow. But again, these are longer in process, but once we start doing them and y'all start doing them, and if there's not the explanation and the pauses, these do not take as long as it did for this one.